All right, so the normal distribution can be used if your sample size is large enough. Otherwise, we need to use a t-distribution. The t-distribution shares many characteristics with the standard normal. You recall, standard normal is the normal distribution where the mean is 0, standard deviation is 1. Both distributions are symmetric, unimodal, a mean of 0, and might be described as bell-shaped. However, the t-distribution has thicker tails. And what this means is that in t-distribution, it is more likely that we see extreme values, that is, values far from 0, than in a standard normal distribution. The t-distribution is always centered at 0, and one difference with the normal distribution is that it only depends on one number, and that's what's called the degrees of freedom. Whereas the normal distribution depends on the mean and standard deviation, the t-distribution depends on the degrees of freedom. And what I mean, the degrees of freedom essentially is a measure of sample size. It describes the precise form of the bell-shaped t-distribution. So, the larger the degrees of freedom are, the more closely the distribution approximates the normal model. And in fact, you see a graph here. The degrees of freedom, when the degrees of freedom is about 30 or more, the t-distribution is nearly indistinguishable from the standard normal distribution. So below are the t-distributions for 1, 10, and 40 degrees of freedom. And in each case, you can see the normal distribution with mean of 0, standard deviation of 1, is drawn in comparison. Even better, let's look at it this way. Here in red in the background, the tall one is the normal distribution, mean of 0, standard deviation 1. This blue one is a t-distribution. Right now it's set for 2 degrees of freedom, but as I increase it, 4 degrees, now 7 degrees, 9 degrees, you can see that as the degrees gets higher and higher, it gets to the point where I really can't tell those two graphs apart. And so this is now at this point, this is where I have 30 degrees of freedom.